In this video we'll prepare nitrous oxide gas via the oxidation of a hydroxylamine salt. First of all, measure out 25 grams of sodium nitrite. Note that's nitrite, not nitrate. Now measure out 40 ml of warm water. Add to the sodium nitrite and then stir to form a solution. The warm water helps because as the crystals dissolve, they cause the solution to cool down. Top the solution up with water so it's around 80 ml in total. Now measure out 25 grams of hydroxylaminium chloride, otherwise known as hydroxylamine hydrochloride. Again, add around 40 to 50 ml of water and stir to dissolve. As before, the solution will cool down as the salt dissolves. You can actually see condensation on the glass here. Now set up a fairly large flask of 500 ml of above capacity equipped with a magnetic stir bar and a ground glass joint. Add the sodium nitrite solution to the flask. Now set up the apparatus with an addition funnel and a way to vent off the gas produced into a tube. If the addition funnel is a pressure equalized one, then you'll need a tight fitting stopper for it. Place the solution of hydroxylamine hydrochloride into the addition funnel. Make sure the stopper is closed. To collect the gas, we'll use the 1-liter beaker filled with water and suspended upside down in a large bowl of water. We've used a magnetic stir bar to prop up one side of the beaker to allow the tube to pass under. Now set up a tube leading from the apparatus and ending directly under the beaker of water. Because the first portion of gas given off will be air displaced out of the apparatus, we'll start by leaving the tube outside the beaker however. So let's start the reaction. Switch stirring on to moderate speed and slowly allow a small amount of the solution into the flask. You'll see bubbles appearing and the solution will start to heat up considerably. As the temperature increases, addition of the hydroxylamine solution results in almost immediate evolution of gas. After a couple of minutes, most of the air should be displaced out of the apparatus, and you're ready to begin collecting. Be careful not to add the solution too quickly because the reaction can become very vigorous if you're not careful, and this could cause a pressure build-up. Gas collection can be pretty fast, as you can see. You'll need to hold or support the beaker in order to stop it tipping over once the level of the liquid inside drops. Once you stop adding the solution, it only takes a minute before the reaction dies down and little more gas is generated. Nitrous oxide is denser than air, and once we collected the full beaker we use a small plate to cover it. Let's see how a burning strip of paper reacts with the gas. Not as vigorously as oxygen, but you can clearly see that the nitrous oxide is an oxidizing agent and supports combustion pretty well. Let's do a final experiment. Here's some finely divided sodium nitrite and hydroxylamine hydrochloride. Let's mix them together dry. The reaction isn't as vigorous as say sodium nitrite with an ammonium salt, but it gives off a lot of heat and some nitrogen oxides in the smoke. A good example of why mixing nitrite salts with anything containing an amine NH2 group can be dangerous unless under controlled conditions. The residue consists of sodium chloride. Thanks for watching and stay tuned.